Okay, so welcome back to another video. Today, we're going to be talking about the pathophysiology of brain injuries. So firstly, if someone, let's say, bumps their head, you can get a primary brain injury, which occurs at the time of the injury. You can also get a secondary brain injury, which actually occurs following the primary event as a result of either hypoxia, hypercarbia, which is high CO2 in the blood, or hypoperfusion, hyper meaning too much, and hypo meaning too little. A reduced GCS may lead to airway obstruction or inadequate ventilation, which results in poor oxygenation, carbon dioxide retention, and acidosis. Let's explain this. Whenever the GCS drops, the muscles in the jaw and the pharynx relax. This causes the tongue to fall back and occlude the airway. This means that the patient can't get enough oxygen into their lungs, which leads to hypoxia. At the same time, they can't offload the CO2, causing the hypercapnia in the bloodstream. Hypercapnia then leads to acidosis. When the CO2 dissolves in the blood, it forms carbonic acid, which lowers the blood pH, making it more acidic. This, in turn, causes a condition called respiratory acidosis. And just another important note we're going to talk about is impact brain apnea. This is an immediate transient cessation of breathing following a head injury, often without significant anatomical insult. The sudden mechanical force exerted on the head can cause autonomic dysfunction, resulting in neurogenic shock, which is characterized by a period of apnea. The lack of oxygen, or hypoxia, is the leading cause of mortality in these patients. So, blood loss from other injuries in a patient with multi-system trauma may lead to hypovolemia, leading to a fall in their MAP or mean arterial pressure and CPP or cerebral perfusion pressure. Let's talk a little bit about the vicious cycle of brain swelling. A TBI can cause initial swelling. This swelling increases the pressure inside the skull, as the skull is a fixed container that can't expand. This pressure is known as the intracranial pressure, or ICP. The cerebral perfusion pressure is equal to the mean arterial pressure minus the intracranial pressure. As mentioned previously, because the skull is a rigid fixed space, any increase in ICP will squeeze blood vessels supplying the brain. As the ICP rises, the CPP falls. Low CPP means the brain isn't getting enough oxygen and nutrients, which can lead to cerebral ischemia. Lack of oxygen causes brain cells to start to swell. I'm not that good at chemistry, so we're not going to go into why that happens, but just know that a lack of oxygen causes brain cells to swell. And because the cells are bigger, it takes up more space and further increases the intracranial pressure. This creates a dangerous positive feedback loop. High ICP leads to low CPP, which leads to ischemia, which leads to cerebral edema, and even higher ICP. That's all for now. Let me know in the comments if you like this short and sweet style, or if you would like a longer video going more in depth.